Hi guys, for today's lesson we're going to be dealing with time series data. So first up, what do I mean by time series data? So it's a sequence of data values that are recorded at regular time intervals. So time series data is literally all about time, doing it over a certain amount of time periods, like doing it on at a regular sort of rate. So for example, you may measure the average temperature records per month. So our regular time intervals here is every single month. You record the temperature, or the average temperatures for the entire month. So next one could be, say, the distance travelled in a truck per hour. Like truck companies may record how far the truck that you're driving is going every single hour. Another one could be, say, the population records every single year. So each one of these is doing it on a regular sort of time interval. So this is the sort of data, this is what the data can look like. So you'll notice that your time in years is going up by one each time. They're recording it every single year. That's why it's going up and up and up 1 year at a time. And you can see down the bottom, the population is changing over time, as you see. Really important to understand that your X variable is always going to be your time, and the other variable, whether it's population or distance or temperature, that is going to be your Y value. Okay, so some rules to remember. So time series data is visually represented by graphing coordinates on the number plane and joining them with straight lines in order. So it's got to make sure it follows this sort of order of time. So I need you to note that the time variable is always on your horizontal or x-axis, and the other variable is always going to be on your y-axis. So let's look at this, set of data, which is time series data. So a company's share price over 12 months is recorded. So you can see that it's been recorded every single month. So that's your time interval. And here is your Y variable, your price. So you need to make sure your time, months, is going to be on the x-axis on this bottom, and the other variable, price, is going to be on your y-axis on the side. This variable going up the side here. It's important to understand. It's important to get your scales correct on these axes. So make sure that you're showing all your months down the bottom. So I went from January all the way to December for that whole year. And with the y-axis, this scale over here, this is a little bit trickier. If you look at your prices, they range from $1.22 to $1.43. Now the idea is this bottom corner here has to be 0. That's how the number plane works. You need this origin here to be the point 0, 0. But however, our prices go from $1.22 to $1.43. We don't really have to worry about anything under $1.22. So the idea is we put this little squiggle here, which is called a break, and that means we can skip from 0 all the way up to $1.20 really quickly. And then from $1.20 we can go up nice and slowly, up by 5 cents at a time, and that will cover our range from $1.22 to $1.43. So these breaks are really handy because we don't want to have to show anything like from $0 to $1.20. There's no point seeing it because we're not going to use any of those values for this data set here. Okay, so when we graph this data set, we just got to make sure that, say, for January, we line up January with $1.30 in this case. So January goes all the way up to $1.30, and we put a dot right there. So it's just about putting a dot at the right spot. It's like the right coordinate. February is $1.32, so we line that up nicely with $1.32. March is $1.35, so we line that up nicely with $1.35, etc. And when you've done that, when you've put all these dots in the right spots, you need to be drawing straight lines between them. And it makes this sort of line graph, what we call it. And we can see here from this graph that we're getting we've had the highest sort of share prices around this time. So it was really high in June, and we can see that it's a lot lower in, say, January and December. It's kind of got its low peaks. Okay, moving on. So time series data typically follow some kind of trend. You've got to be able to deal with the idea of a trend with these sorts of data sets. So first up, we can have a linear trend. So a linear trend means a straight line trend. So you can see here with this sort of graph, you can see it's kind of going up at a straight line. It's not a perfect straight line. It doesn't have to be perfect, but it roughly makes a nice uphill line. And that we call that a positive trend or an uphill trend because it's going uphill. This sort of straight line one, it's a bit jagged, but it's still roughly going in a straight line over, like, if you kind of look at it, it does make a relatively straight line. And you would say that is a negative trend because it's a bit of a downhill sort of straight line. So it doesn't have to be a perfect straight line, but it's roughly following generally a sort of straight line, if that makes sense. Okay, so next up we have a non-linear trend or a curved trend. So non-linear means not straight. And if we kind of have a look at the sort of shape that this trend is making, it kind of looks like this sort of curvy line. You can see it's going up here and then it kind of starts to flatten out. So we'd say that is a non-linear trend. It's a curved trend. It looks like it's going to keep flattening out. It's definitely not a straight line. It's definitely not a linear curve. And then lastly, you've got the no trend pattern where it's quite random. You can see here that it's definitely not following any sort of straight line. It's definitely kind of going up and down, up and down. It's not following a curved line. It's like very jagged. It's all over the place. So therefore, we would say that sort of pattern or that sort of time series data has no trend, right? It's a random pattern. I hope this helps with the questions. Good luck.